All right, let's start the class. Okay, since our last class is last Friday, right? So it has been 1 week, right? So let's review the chapter 14 together again. All right, so we say before this chapter, we talked about the hypothesis test or the confidence interval is only for one population, right? And then for this chapter, for the chapter 14, we have two populations, right? For example, one population for women, one population for men. And then I want to compare the population means for these two populations. So what should I do? We actually randomly select one sample from one population and randomly select another sample from another population, right? And then we use the information, for example, the sample means, the sample standard deviations, the sample sizes to make the hypothesis test or the confidence interval about the two population means, right? So that we can compare which one is larger, which population has larger population means. All right, so actually we say this is our goal, right? So we want to compare which one is larger, right? So we can compare mu1 larger than mu2 or less than mu2 or just different from mu2, right? Since for this format, we don't know how to make the hypothesis test or the confidence interval, right? In this case, we just convert it to the format we are familiar with, right? So if we want to compare the mu1 larger than mu2, then I can test the same thing, mu1 minus mu2 larger than 0. So that to the right of your hypothesis is just a number, a value, right? And then to the left of the hypothesis, we define it as the big delta, right? So we call it is the difference between the two population means. So this is again a population parameter. To the right is a value we want to test about, right? So this format we are familiar with because in the chapter 12 to chapter 13, we have already done this kind of hypothesis test before, right? Okay, and then we say to get this two sample test, we have always, since this is for the hypothesis test, we still have these 4 steps, right? We first state the hypothesis, and then we calculate the test statistics. And based on the test statistics, we find the p-value. And then we use this p-value compare with our given significance level alpha to make the conclusion. Right. So for the first step, um, we say for this part, this is a special case, right? So for this special case, I don't care mu1 is larger than mu2 by what amount. I just want to compare these two. Right? As long as I can know mu1 is larger than mu2 or less than mu2 or just different from mu2, that will be fine. Right. Then we have this special case for the two sample test. That means we just test about the difference about the 0. So this 0 is also our claimed difference that we want to test about. Right? And then we say the more general case will be we not only want to test which one is larger, we also want to test mu1 is larger than mu2 by what amount, right? So for example, I want to know the population mean weight of men, whether the population mean of men is larger than the population mean weight of women by 10 pounds. Right? So first, we have 2 things to test. The first thing is the population mean of men is larger than population mean of women. And then I also want to test the difference, the claimed difference, which is our delta 0, right? So this is also our claimed difference. right? So we say that 0, this is a special case in our general hypothesis. Right? If we just want to compare mu1 and mu2, then the claimed difference, the delta 0, is just equals to the value 0. All right. And then once we state the hypothesis, we say we need to calculate the test statistics. So we say to calculate the test statistics, we need to use the formula. We say whenever you want to use the formula, we need to check the assumptions, right? So in the previous chapters, when we check the assumptions, we say we only have one sample, we have one population. Then we need to check the independence assumption and normality assumption, right? Since we are testing about the population mean, the independent assumption, we need to make sure the sample is randomly selected, the sample size is less than 10% of the population size, right? And for the normality assumption, we say we need to make sure the sample size is larger than 30 so that we can apply the central limit theorem, right? To say the sampling distribution is normally distributed, right? Okay, so now we have two samples from two populations. Then we need to check the independent assumption and normality assumption for both samples, right? So that means we need to make sure both samples are randomly selected, both sample sizes are 10% are less than 10% of the population size. Right. For the normality assumption, we need to make sure both sample size are larger than 30 so that we can apply the central limit theorem, right? But now we have two samples, so we have another independent assumption to be checked because we want to make sure the two samples don't have any relationship, right? So if one sample is obtained with husbands and another sample is collected with their wives, then they have some relationship, right? So in this case, will not be independent. All right. So we say we need to check all of these three assumptions, and when all of these three assumptions are all satisfied, we can calculate the test statistics by formula, right? So we say whenever we want to deal with the population mean, we always have two cases. One case is when the population standard deviations are given. Then we have the z-test statistics, right? And the other case is if sigma 1 and sigma 2 are unknown or either of them is not given, then the z-test statistics will change to t-test statistics, right? Okay, and then we say if the sigmas are both known, then the z-test statistics, this formula will be y1 bar minus y2 bar minus delta 0. So what is this y1 bar minus y2 bar? It's the difference between two sample means, right? So this is the sample mean of sample 1. This is the sample mean of sample 2. Right, so we say we want to test about mu1 minus mu2. Then here will be the sample mean 1 minus sample mean 2, right? Minus delta 0. So what is delta 0 again? The delta 0 is, in our step 1, the delta 0 is the claimed difference we want to test. Right? It's the value in our hypothesis. Right, so this is delta 0. We call it is the claimed difference. All right? And then divide by the standard deviation of y1 bar minus y2 bar. So what is that? Sigma 1 squared over n1, sigma 2 squared over n2. All right. And then similarly, if the population standard deviations are not given, then you have t-test statistics. And then similarly, you have the difference between the two sample means minus the claimed difference. Joe, any question?
I'm all good.
Okay. And then divide by the standard error. So now we divide by the standard error, not the standard deviation anymore, because we don't have the population standard deviations anymore, right? So we have the S1, which is the sample standard deviation squared over N1, plus sample standard deviation 2 divided by N2. Right? So actually step 2, once you figure out, you use the z-test statistics or t-test statistics, you just plug in the values into the formula so that you can calculate the test statistics. All right, and then we say this step is very, very important because you will use the test statistics to find your p-value from different tables, right? So we say if you have z-test statistics, if the population standard deviations are given, then you use the z-test statistics, go to the z table to find the p-value, right? So we say if your hypothesis, right, if your alternative hypothesis is a right tail hypothesis larger than the claimed difference, then what will be your p-value with your z-test statistics? Your p-value will be the probability to the right of your z-test statistics. Right? So that means you use your z-test statistics, go to the standard normal table, find the probability to the left of z-test statistics, right? And since it is a right tail hypothesis, your p-value will be 1 minus whatever you find from the z table to get the probability to the right, right? And then the other way, if you have the left tail hypothesis, then what is your p-value? The p-value will be the probability to the left of your z-test statistics, right? So this left tail will be your p-value. So since whatever you find from the standard normal table, it is already the probability to the left, right? So you don't need to subtract from 1. Whatever you find from the table, that will be your p-value, right? And then if we are testing about the two-tail hypothesis, that means your p-value will be this tail plus this tail, right? So you can find either one and then times 2. So the way to find the p-value will be exactly the same with what we did in the previous chapters. So if you have the z-test statistics, we go to the z table to find the probability to the left, to the right, or the two tails, right? And then the other way, if you have the t-test statistics, how you can find the p-value? We say once you have the t-test statistics, you go to the t table, right? And then in the t table, we say it's always one column called the degree of freedom. That means we always need to fix the degree of freedom first, and then find our t-test statistics should between two values in this line, and then your p-values range will be found from the first line. Right, so that will be your range of your p-value. Okay, the only difference for the two sample test is your degree of freedom will not be n-1 anymore. Your degree of freedom will be calculated based on this big formula. All right, and then what is good is if the degree of freedom is not given to you, you can always use this, the Excel I gave to you on Canvas, and then put in the value of N1, the value of N2, the value of S1, the value of S2 to calculate the degree of freedom automatically. All right, so from the step 3, you either find the p-value from the z-table, which is the exact p-value, or if you have the t-test statistics, you find the range of the p-value, right? And then based on your p-value, the last step will be exactly the same with the same rejection rule. We say if the p-value is less than the significance level alpha, then you reject the null hypothesis. We have enough evidence to support our claim. Right? The other way, if your p-value is very large, larger than the significance level alpha, everything changed to the opposite, right? We do not reject the null hypothesis. We do not have enough evidence to support our claim. Right? So this is about the hypothesis testing about our claimed difference. That means what? That means before this hypothesis, we have our own idea about this difference, right? I think mu1 should be larger than mu2 by 10 pounds, right? So this 10 is my claimed difference. This is my idea. I can test about any value I want, right? But what if I don't have any idea about this difference? I just want to know or learn some general idea about the difference. Right? Then we can get the confidence interval for the two population means. That means we can get a confidence interval for mu1 minus mu2. Right? I do not have my own idea to test about. I just want to know how large will be the difference. Right? The difference will be in what kind of is between maybe between 5.5 to 10.5, something like that. Right? Kind of get an idea about the difference. Right? Then we say for any confidence interval, we have a general format, which is the estimate plus minus the margin of error. Right? So since we still want the confidence interval for the population mean, we need to take care of two cases again, right? Depending on whether the population standard deviations sigma 1, sigma 2 is given, they are given, or they are not given. All right, so we say when the both population standard deviations are given, then we have the y1 bar minus y2 bar, the difference between the sample means to estimate what? To estimate the difference between the two population means plus minus the margin of error. Margin of error will always be the critical value times the standard deviation or standard error. Right, so in this case, since these two are both known, then we have the z star times the standard deviation. All right? And then we say the standard deviation here will equals to the square root of sigma 1 squared over n1 plus sigma 2 squared over n2, right? So if I put them together, that means we have the formula y1 bar minus y2 bar, which is the estimate for the difference of the population mean, plus minus the critical value z star times the standard deviation of the difference, which is square root of sigma 1 square over n1 plus sigma 2 square over n2. Right, so remember this z star is called the critical value. It's totally different with the z-test statistics. Right, we will talk about that. We'll talk about the difference later today. Don't get confused. We use the z-star for the confidence interval. We use the z-test statistics for the hypothesis test, right? So for the z-star, how you can find the z-star? We remember them, right? 1.645 for 90%, 1.96 for 95%, 2.576 for 99%. Right? Okay. And then the other way, if the sigmas, if the population standard deviations are not given, then we still have the difference of the sample means to estimate the population means, plus minus the margin of error. So now this margin of error will be changed from the z star to t star. Standard deviation changed to standard error. All right, so now the point is how we can find this t star. Say the t star is also called a critical value. We call it is the t critical value. Right? To find the t star, we say we need two information, which is the degree of freedom and alpha over 2. Right? So we have the degree of freedom, we just focus on this line, and then combine with alpha over 2, which is to the top of the t table. Combine together, you find the t star from the t table. So you do not have any formula to find this t star. You just go to the t table, combine with these two information together, and then you get this t star. All right. Okay, so then we say we have the estimate plus minus the margin of error, and then we say combine these two together. We have a general formula. We have y1 bar minus y2 bar estimate, right, plus minus the t star. And this t star depends on the degree of freedom and alpha over 2. Right? And then times square root of, now we do not have the population standard deviations, so we use the sample standard deviation plus another sample standard deviation squared over n2. All right. Okay, so once the confidence interval is calculated by this formula, we always need to make the interpretation of it. Right? So we say once this confidence interval is for mu of men minus mu of women, that means when you calculate the confidence interval, you need to use what? You need to use the sample mean of men minus the sample mean of women. So that means the order matters. Right? If you want to get the confidence interval of men minus women, that means in the formula, at the beginning of your formula, you need to follow the same order. right? So for example, if I got a 95% confidence interval for men minus women, which is 10 pounds to 15 pounds. So how you can interpret your confidence interval? We say we do not care, actually we do not care about this difference. We care about which one is larger and larger by what amount, right? So then our interpretation of the confidence interval will be we are 95% confident that since it is a positive confidence interval, that means this difference is positive. That means what? That means the men is larger than women by what amount? By 10 to 15. Right, so the complete interpretation will be we are 95% confident that the mean weight for men is higher than women. So it tells us the first information, right? The men is larger than women in Ohio by the amount of 10 to 15. All right, so you cannot just say we are 95% confident that the difference between men and women is 10 to 15 pounds. It is not a complete interpretation. Right, okay. And another way, right, if my confidence interval is about the women minus men, that means what? That means when you calculate this confidence interval, you will need to use the Y bar of women, the sample mean of women minus the sample mean of men, right? So the order is changed. That means your confidence interval should be the negative confidence interval. But you cannot interpret a negative weight, right? It doesn't mean anything. So in this case, you need to change your way. We say women minus men is negative. That means women is less than men. By what amount? Now you need to change this confidence interval to positive confidence interval and switch their order, right? So that means the women is less than men by what amount? By 10 to 15 pounds. Because your confidence interval is negative, right? So if it is negative less than 0, that means women is less than men. By what amount? By 10 to 15. All right. Okay. And then that will be all for this chapter. So last class we went through just the first half of this example, right? So we say, again, this is about I want to test which system has the users that spend more money, right? So based on these two samples, so one sample from the system A users, one sample for the users using system B, right? So the first sample, I have 55 of them. The second sample, I have 57 users from system B, right? So that means I have two samples collected. And then here, I just want to know which system has users that spend more money. I don't care A is larger than B by what amount, right? I just want to know who is larger. So based on the sample means, it looks like what? It looks like system A has the users spend more money than the users using system B, right? So that means I kind of want to test whether the mu of A is larger than mu of B. The population mean of A larger than the population mean of B. But we do not have this kind of hypothesis, right? We need to change it to mu of A minus mu of B larger than 0. then this will be our alternative hypothesis, right? So once we figure out what is our alternative hypothesis, that means at the same time, you know the value of your claimed difference, delta zero, which is just the value of 0, our claimed difference, right? Okay, and then we say this is the first step, and next step, before we calculate any test statistics, we need to check the assumptions, right? So we say we have 3 assumptions: independent, and normality. So for the first independent assumption, we need to check both samples are randomly selected, checked, right? And then for the both sample size, the sample size here is 55 for A, 57 for the sample B, right? And then we say the population is the whole smartphone market. So of course the population is large, right? So in this case, the 10% condition will be checked. All right, and then for the second independent assumption, we need to make sure these 2 samples don't have any relationship. Right, so in this case, what? Let's say the users using system A should not have any relationship with the users who use the system B, right? And then that means these 2 samples are independent of each other, checked. Right? And then the last one, the normality assumption. That means we need to check that both sample size is larger than 30, right? So that we can apply the central limit theorem. All right. So after we check these 3 assumptions, we can calculate the test statistics based on our formula. Right, so remember when we calculate the test statistics for the population mean, we have 2 formulas. We have either this z-test statistics or the t-test statistics. Right, we need to decide which one do we need to use. So in this case, in our example, you use the z-test statistics or the t-test statistics. Alex, do you think?
We're going to use T because they only give us the sample standard deviation for each sample.
Perfect. Yes. Thank you, Mary. Yes. Right. So in this case, when you read the question, the information we have is all about this table. Right? So in this, what is this table? This is the summary of the results, the result of these 2 samples, right? She randomly selected samples, users from each operating system, and measures how much money they spent on the app in the past month. And here is the summary of the results. So you have one sample with 55 users, another sample with 57 users, right? So this is the sample selected from system A. This is another sample selected from system B, right? So this table is all about the 2 samples. We only have the sample standard deviations. We do not have the population standard deviations, right? So in this case, we say since sigma 1, sigma 2 are unknown, we need to use the t-test statistics, right? And this is the formula for the t-test statistics. We just plug in the sample mean for A minus the sample mean for B minus the delta zero. So what is the delta zero? This is the claim the difference in your hypothesis, right? So what is our hypothesis? this is our hypothesis, right? So the delta zero is our claimed difference, which is just a 0, right? So just minus 0 divided by square root of the sample standard deviation, which is 5 squared over sample size 55 plus the sample standard deviation is 3 squared over sample size 57, right? And then after calculate that, you have this. What is this value? This is the t-test statistics, right? So we say this step is very important because it would decide the next step. You go to the z table or the t table, right? So once you have the t-test statistics, of course you need to go to the t table to find the range of your p-value, right? So that means you first focus on your degree of freedom line, right? And then you find this 3.833, which is your t-test statistics, should be between two values. And then you go up to find the range of your p-value, right? So the only thing left for us to find the p-value is to determine what is the degree of freedom, right? So we say we can plug in the sample size S1, which is, this is S1, N1, S2, N2, right, into the Excel so that the degree of freedom will be given to you, right? So in the last class, we have already showed how to find the degree of freedom by the Excel, right? So after you calculate the degree of freedom, which is 88, then we can go to our table, which is t table, because we have t-test statistics, right? And then we just focus on the line of 88. Right? And then based on this line, we find our test statistics. Our t-test statistics is calculated as 3.833. Right, so where is our 3.833? The largest value in this line is 3.4. So that means this 3.833 should be to the right of 3.405, would be somewhere here. That means if you go up to the top line, that means your p-value should be even less than this 0.0005, right? So that means you find the range of your p-value, which is less than 0.005. And since our alpha is given by 0.01, so since your p-value is already less than 0.0005, of course it is less than 0.01. Right? So now we know p-value is less than alpha. It means we reject the null hypothesis, right? Is this our conclusion? Not yet, right? So we need to make the conclusion about our claim. What is our claim? In our alternative hypothesis, we say we want to test the mu of A minus mu of B larger than 0. Is this our claim? Actually, not, right? So this is changed from what? From our original goal of this hypothesis, mu of A larger than mu of B. So actually, this is the claim we have, right? So that means if we have enough evidence to support our claim, that means we have enough evidence to support that the users using system A spend more money on the app than the users using system B. So this will be your complete conclusion about your claim. Right? We do not care about their difference. We care about who is larger. right. Okay. And then with the same background, with the same samples here, right? We do not want to test about anything. I just want to know what will be the difference between these two systems. Right, that means I want to find a 95% confidence interval for the difference between these two systems. That means I want to find the confidence interval for mu of A minus mu of B. Right? Okay, so to find the confidence interval, remember the first step is always to check the assumptions. But since in the hypothesis test we are dealing with the same situation, the same background, then we can skip this part because we have already checked the assumptions. Right? But remember, the assumptions is always your first step for computing a confidence interval. All right, since all of these three assumptions are all satisfied, then we can use the formula to find the confidence interval. Right, so again, for the confidence interval about the difference between two population means, we still have two formulas. Right, so this one or this one. Right, so again, in the last question, we have already know that the population standard deviations are not given, right? That means we will use this formula. So that we have the difference between the two sample means plus minus the t star times the standard error of the difference. Right, so we just plug in the difference between the two sample means, 13 minus 10 plus minus, and then the standard error is also given 5 squared over the sample size, right? And sample standard deviation squared over the sample size. The only thing left would be our t star, right? So how to know this t star? We find from the t table. Right? And then to find this t star, we need two information, the degree of freedom and alpha over 2. Right? So we know the degree of freedom is calculated as 88. Right? And then alpha over 2, this alpha is 1 minus the confidence level. Right? So we want a 95% confidence interval. That means the alpha will be 0.05, right? Divide by 2, which is 0.025, right? So that means we combine these two together so that we find this t star on the t table, right? So that means we go to the 88 line, which is our degree of freedom, right? Combine with t of 0.025, go down, and then combine these two together, you have 1.987 as your t star. All right. Okay, so once you just plug in all the values into this formula, you have your confidence interval, right? So you have your confidence interval and you need to change it to this interval format, right? You will find your confidence interval as 1.445 to 4.555. So how you can interpret this confidence interval? We need to answer two questions, right? The first one, who is larger? The other one, larger by how much, right? So first, this is the confidence interval for mu of A minus mu of B, right? So we have a positive confidence interval. That means A is larger than B by what amount? By 1.445 to 4.55. Right? So if we have a complete interpretation of the confidence interval, we need to say we are 95% confident that who is larger? The users using system A spends more money than the users using system B. By what amount? By the amount of this interval. All right, so in your data analysis 1, if you look at the rubric for the confidence interval interpretation part, you will see a rubric that you need to define, define the variable. All right, so what does that mean? Normally, if I don't know anything about the meaning of mu of A, mu of B, so I can say that we are 95% confident that the mu of A is larger than mu of B by this amount. But now we have the detailed meaning for mu of A and mu of B. Then you need to make sure you have the complete interpretation of what does the mu of A means, what does the mu of B means. Right, so mu of A is the money the users spend by the system A, right? And mu of B is the users spend on system B, right? And then this is how you define your variable. So we have these two variables, but you need to make the real meaning in your real data analysis. All right. Okay, so the last part for this chapter is again for the jump practice, right? So you should be very familiar with the steps for two sample tests. We still go to the help, all right, and then sample data, all right, and then the screen again showed up, and then we go to the calculators. Right, so in this calculators, we have already tried for the confidence interval for one mean, the confidence interval for one proportion, right? We also tried the hypothesis test for one mean, hypothesis test for one proportion. And now we can try the hypothesis test for two means to compare the two population means, right? So if we click that, here we still have three options: raw data, summary statistics, two samples in two columns. Right, so if you have the detailed value for each sample, then you can choose the two samples in two columns. Otherwise, since for our example here, summary statistics, right? So we only have a table with all summaries. We have the sample sizes, we have sample mean, we have sample standard deviations, right? But we do not have the detailed value for every observation, right? So we choose the summary statistics. All right, and then we say we will have this screen again, very similar to the previous ones, right? So here you still need to choose your type of your test, right? So if the both population standard deviations are given, then you have the z-test, right? Otherwise, if the population standard deviations are not given, then you need to use the t-test, so that you only need to enter the sample standard deviation 1 and sample standard deviation 2. All right, and then here when you choose the t-test, you have one more option to choose. One is called the equal variances, another one is called the unequal variances. All right, so this option is kind of two ways for the two sample t-test. what we learned here is actually we assume the population standard deviations are not equal. Right, so we just choose the unequal variances. Right, and then we say to choose the type of the alternative hypothesis. Again, you need to figure out you want to test the two-tail, the left tail, or right tail hypothesis. Right, the only thing left or only thing you need to be careful is when you enter the values here, you need to figure out which one is your mean 2, which one is your mean 1. Right, so in our case, in our example, we say in our alternative hypothesis, we want to test mu A minus mu B is larger than 0. That means what? That means your 2 in the jump here is the system A. The mean of 1 is for system B. That means when you enter your sample means, sample standard deviations, and sample size, make sure the sample 1 is about what? The sample 1 is about the system B. Sample 2 is about the system A. The order is reversed. Right, so when you enter these values, you need to be very careful. All right, okay, and then everything else will be the same. Once you enter the significance level, you just enter, and then you have all the test results, right? So this is what? This is the sample mean difference, right? And since you have the t-test statistics, you have the standard error, right? You have the t critical values. No, this is not the t critical values. We are doing the hypothesis test, right? So we need the t score, which is our t-test statistics, right? 3.833. In the end, this will be our p-value, which is 0.0001. All right, and then based on our alpha level 0.01, of course, we reject the null hypothesis. All right, okay, so that will be all for chapter 14. Any questions? No? All right, and then next thing I want to talk about is your essay assignment 2. Right, so since essay assignment 2 is also the hypothesis test, I don't want you to make the same mistake for the essay assignment 3. All right, so now I want you all to go to Canvas and then open your assignment 2 submission on Canvas. All right, and then when I explain or talk about these 2 exercises, try to grade by yourself, right, to see how well you did for the last assignment. All right, okay, so we say for the exercise 1, the question is quite clear, right? So we say, what do we want to test? We actually want to test that whether their new brake system achieves a shorter mean stopping distance than 60 feet. Right, so this is the thing we want to test. Actually, we are testing about the population mean, right? So for the first step, state the hypothesis. I see several problems. The first problem I saw is, remember the hypothesis is always in pair. You cannot just give me, okay, I state the hypothesis, my alternative hypothesis is mu less than 60. This is not a hypothesis. The hypothesis should be as one pair, null hypothesis and alternative hypothesis together. All right, so this is the first thing. The second thing about the hypothesis is I see some of you just kind of, I don't know what does that mean, but you just don't like the mu, right? So you just state that your hypothesis is equals to 60 and larger than 60, less than 60. Is this a hypothesis? I don't think so, right? So remember, when you state the hypothesis, you always need to specify you want to test about the mean or the proportion, right? Okay. Okay, so this is about our first step, state the hypothesis. And then for the step 2, remember, every time you calculate by any formula, remember to check the assumptions, right? Even after the assignment 1, I still see some of you just escape this step, right? Never forget to check the assumptions, right? So in this case, we say we are testing about the population mean. So we have the independent assumption, that means randomly selected 10% condition, right? For the normality assumption, we say since we are testing about the mean, we just check the sample size, whether it is larger than 30 will be okay. All right. So after this assumption are both satisfied, then you can use the formula to calculate the test statistics. Right, so here, remember, before you use the formula, when we test about the population mean, we have 2 formulas, right? One is when the population standard deviation sigma is given, then you have the z-test statistics. Or if the sigma is not given, then you have the t-test statistics. Right? So don't think that if you have the right answer or right value here, you will be fine, right? It is not fine. You need to specify you have the t-test statistics or the z-test statistics. Right? Okay, and this is the first problem I see. And another problem is I see some of you use the different formula. You use the z equals to x bar minus mu 0 over sigma. This is not the formula for the test statistics. This is the formula for the test statistics. Right? Don't forget to divide by square root of the sample size. Right, so this is about the test statistics. And then we say, once you have the test statistics, it is the t-test statistics, right? That means you need to go to the t-table. That is why I keep saying that always determine you have the t or z before the steps 3, because you need to decide you go to the standard normal table to find the p-value or the t-table to find the range of the p-value. Right. So from the last step, we already know that this is a t-test statistics. That means we need to go to the t-table. Right, to go to the t-table, we need to first focus on your degree of freedom, right? And then figure out your test statistics. We make it absolute value. We just care about the positive part. 3.08 should be between 2 values. Go up. That means this is your p-values range. All right. So since this is one sample test, degree of freedom is just a n minus 1, right? So you have 81 minus 1, degree of freedom 80. You have the t-test statistics that you check 3.08 in the t-table. So that you just focus on the 80 line, right? 3.08 is between these two. right? That means you go up, find the range of your p-value. That means your p-value is between 0.005 and 0.001, right? So that means you have this range of the p-value. So only when you have the p-value, you can compare with the alpha, the given significance level alpha, so that you can make the conclusion. Right here, again, if you just stop here, give me the conclusion, say, okay, p-value is less than alpha, we reject the null hypothesis, no credits, right? This is not your conclusion. What is your conclusion? Your conclusion is always about your claim. So what is your claim? We want to test whether their new brake system achieves a shorter mean stopping distance than 60 feet. Right. So if you just stop here, say reject or not reject the hypothesis, this is not a conclusion. All right. Okay, and from this question, I also see that some of you don't know how to find the p-value. Instead of p-value, you find something, some of you use t star, some of you use the z star. Right, so remember in the hypothesis test, we do not have t star or z star. The t star and z star are critical values that we will use for confidence interval, not in the hypothesis test. Right, don't get confused. You use your test statistics, go to the table to find your p-value so that you can find or make the conclusion based on the relationship between the p-value and alpha. If you don't have p-value, how you can make the conclusion? All right, okay, so this is about your first exercise. And for the second exercise, the problem just happened to the first step, state the hypothesis. Right, so when you state the hypothesis, especially for the alternative hypothesis, what is your alternative hypothesis? The alternative hypothesis should be, what do you want to test? Right? It's not just you have a paragraph and then you just read about it and then find the keywords, right? Once you see, okay, I see a keyword difference from, then it is two-tailed. Is that real two-tailed? Is this sentence just ask you or tell you what do you want to test? We will assume that 50% believe the method is unethical and that any apparent difference from 50% is just a random fluctuation. Is this sentence tell you what do you want to test? Of course not, right? So this sentence just is a statement, kind of give you an introduction about what does this 50% mean. It didn't tell you what do we want to test. Right? So what do we want to test really? When we read the first sentence, suppose we wish to prove that a majority of market researchers believe that a certain survey method is unethical. This is the thing we want to test, right? So how we can figure out what do we want to test? We want to test whether a majority of market researchers believe that this survey method is unethical. Majority, that means proportion larger than 50%, right? Then this will be your alternative hypothesis. Don't get confused with something you think is keyword. It is not always the keyword. All right, so for the first hypothesis. First step, state the hypothesis. Right? You need to figure out what is your alternative hypothesis. Right? The second thing about the assumption. Right? So for this assumption, some of you forget about the assumption. Some of you got confused with the normality assumption. We are testing about the proportion. What should we test, or what should we check for the normality assumption? Do we still check the sample size larger than 30 so that we can apply the central limit theorem? No, right? This is for the normality assumption for testing about the population mean mu. Now we are testing about the population proportion. What do we check for the normality assumption? Success and failure condition, right? So number of successes larger than 10, number of failures also larger than 10. All right. And then once these two assumptions are both satisfied, then we always have the z-test statistics for the proportion, right? So you can plug in the values. So we have the z-test statistics equals to p hat minus p0 over square root of p0 q0 over sample size n. Right? So when you calculate this z-test statistics, there are several things to be careful. Right? The first one, in the square root, in the bottom of this formula, right? Here is P0 times Q0 over N. This is not P hat. P hat is the sample proportion. P0 is the hypothesized value in your hypothesis. So we have the P hat is 0.57. P0 is 0.5. Right, so when you plug in the values, here should be square root of 0.5 times 0.5. It's not 0.57 times 0.43. Right, be careful. Here should be P0, Q0, not P hat, Q hat. Right, so this is the first thing. Second thing is some of you have the after the calculation, even though you have exactly the same entries, you have 2.01 or 2.02. It doesn't matter, right? This is not a math class. I don't care whether you keep how many decimals. If you want to keep 3 decimals, 4 decimals, 2 decimals, I don't care about that. All right, what I care is whether your entries are correct. All right, so this is about the second step. And next step, since you have the z-test statistics, how to find the p-value? We say z-test statistics always goes to the z table, right? We have the z-test statistics 2.0, so it will be 2.00, right? So that will be here, which is 0.9772. Is this your p-value? We need to check our hypothesis, right? So our hypothesis is a right tail hypothesis. That means the p-value should be the probability to the right of your z-test statistics. But whatever you find from the z-table is a left probability, right? So what is your p-value? 1 minus. All right, so once you have the p-value, then the only thing left will be making the conclusion. We say for if the alpha is 0.05, so of course your p-value is less than the 0.05. So we reject the null hypothesis. Do not stop here. You need to continue. What is your real conclusion? We want to test whether the p is larger than 0.5. So what does that mean? Whether the majority of the market researchers believe that a certain survey method is unethical. Right? The other way, if the p-value is larger than alpha, that means we do not have enough evidence to support our claim. All right. Okay, so that would be the essay assignment 2, right? I do not want to see the same mistake or same problem show up in your essay assignment 3. Right, so essay assignment 3, I will not give you full points for the completion, right? I will just grade if you miss the assignment, if you miss the assumptions, 2 points off, right? If you miss the assumptions for both questions, then 4 points off, right? So think about that, right? Don't make the same problem. All right, and then another 10 minutes. All right, so I want to talk about, since from your essay assignment 2, I see that some of you just got confused with the difference between the hypothesis test and the confidence interval. Right, so let's just make a short summary. Right, so we say for the hypothesis test, right, so we say we follow the 4 steps. Right, state the hypothesis. Before we calculate the test statistics, we need to check the assumptions, right? So then we need to calculate, we call it is the test statistics. This test statistics including either a Z test statistics or T test statistics, right? So how we can get this test statistics? Do we find it from the table? Where do we get this test statistics? We have the formula, right? We need to plug in the values into the formula so that we can calculate the test statistics. And once we have the test statistics, we use this test statistics to find the p-value, so that's the last step. Use the p-value, compare with alpha to make the conclusion, right? So that means before the last step, do you use alpha for hypothesis test? You do not need the alpha, right? You only need the alpha when you have the p-value. When you want to make the conclusion, you just compare your p-value with alpha. Before that, you even don't need the alpha. All right, but what if I want to get the confidence interval? In the confidence interval, we also have the Z star or the T star. What are they? They are not the test statistics. They are called the critical value. So from the name, you will see they are totally different, right? So they are totally different things. These critical values are not from calculations, are not from any formula. You just find them from the table, right? For the Z star, you even don't need the table. You just remember them, right? Or you can find from the last line of the T table, right? So in here, you can find 1.645, 1.96, 2.576. Right? So actually, you don't need to calculate anything for the Z star in the confidence interval. The T star, that means you need to combine the degree of freedom and alpha over 2, which is 1 minus the confidence level divided by 2 to find your T star. You still don't need any formula. You don't need to calculate anything to get this T star. Right? So you see the difference? That means when you get the confidence interval, in the process to get the confidence interval, calculate the confidence interval, you need the Z star or T star, you need the alpha level, you need the confidence level. But for the hypothesis test, until the last step when you want to make the conclusion, you do not need the alpha. You just calculate by the formula to get the test statistics, and then you find the p-value from the table and then compare with alpha. Right? Okay, so this is about the hypothesis test and confidence interval. And some of you also got confused about when to use the Z, when to use the T. Let's just summarize a little bit about this, right? So we say it doesn't matter if we want to get the hypothesis test or the confidence interval, right? If it is about the proportion, if it is about the P, then you do not have any other options. You just have the Z. So for the hypothesis, you have the Z test statistics you calculate from the formula. For the confidence interval, you just find Z star. Right? So we say for proportion, you do not have two options. You just have Z's. Right? And then for the hypothesis test or the confidence interval, for the population mean, for the mu, then whenever you want to test or confidence interval about the population mean, you have two options. Right? So you either have two options, right? So you either have the Z test statistics or the Z star for the confidence interval when the sigma is given. Then we still have the Z, no problem. But what if your sigma is unknown? Then you will have the T test statistics for the hypothesis test. You will have the T star for the confidence interval. Got the idea? All right. Okay. So that will be all that I want to talk about. And another thing is in your home page, right? So in your home page, just below the WebEx links, right? You have the class schedule here, right? I keep getting email from you that's checking the date of the exams, right? So you have the detailed course schedule, right? So you just check this schedule and then you will find, okay, so that means after today, we have one more week to go through the chi-square tests, right? And then after next week, we have our exam week, right? So the first day, which is on Wednesday, we will have a review class, and then next class we will have the exam one, which is on next Friday. All right, so I think it is a good point for you to start review, and then I think spend another week for the chi-square test. I think that would be good for the exam one. Right, and I think I just got the final exam date and location. I will let you know both on the homepage and also through the announcements, right? So just look at the host homepage will be okay.